Good morning, everyone. So, welcome to my YouTube channel, myself, Ram. So, today we are going to see certain lecture on linear transformation. Today we will study the null space and range space of a linear transformation. Let V and W be two vector spaces vector spaces over the same field F and let T V to W be a linear transformation. We write NT is equal to collection of all those elements in V which map to zero element in W. Then when NT is called the null space or kernel kernel of T. So it is called NT is called null space of T or kernel of T. So theorem one. Let V and W be two vector spaces vector spaces over the same field the same field F over the same field F and let T V to W be a linear transformation. Formation. Then null space of T is null space of T null space of T is a subspace of V. Proof. So obviously NT is what? NT is V belongs to V such that TB is mapped to B is mapped to 0 under A. So obviously this is subset of. We know 0 belongs to vector space and G T linear transformation takes 0 to 0. So this implies V G belongs to 0 belongs to NT. So this implies NT is not equal to 5. Now let V1, V2 belongs to V and alpha beta belongs to field. V1 and V2 belongs to V implies so V1, V2 belongs to NT. Now V1, V2 belongs to NT implies T V1 is equal to 0 and T V2 is equal to is equal to 0. Now alpha V1 minus beta V2 belongs to B with T alpha B1 minus beta B2 is equal to alpha times T B1 minus beta times T B2. If you say 0, you say 0 minus 0 is equal to 0. So alpha B1 minus beta B2 belongs to B such that P alpha B1 minus beta B2 is equal to 0. This implies alpha B1 minus beta B2 belongs to NT. For all V1, V2 belongs to B and alpha beta belongs to F. So this implies NT is a vector subspace of V. Okay. Now range space. That V and W, V2 vector spaces over the same field F and let T V to W be a linear transformation be a linear transformation we write RT is equal to T. We collect all TV where B belongs to B. Then RT is called range space of theorem 2. Let V and W be two vector spaces over the same field F, and let V to W be a linear transformation. Transformation. Then range space of T is a vector space, vector subspace of W. So what is RT? RT is nothing but V. V belongs to. Now 0 belongs to V. This implies 0 is equal to P is equal to RT. So this implies 0 belongs to RT. This implies RT is not equal to 5. Now that W1, W2 belongs to RT and alpha beta belongs to field. W1, W2 belongs to RT implies there exists V1, V2 belongs to V, such that V1 is equal to W1 and W2 is equal to V2. Now W1, W2 belongs to RT, that is subset of W, and alpha beta belongs to field. So this implies alpha W1 minus beta and W2 belongs to W, because W is a vector space. And alpha W1 minus beta W2 is equal to alpha TV1 minus beta TV2. This is T alpha B1 minus beta B2. We have alpha B1 beta B2 belongs to B and since alpha B1 beta B2 belongs to B, we have T alpha B1 beta B2 is equal to RT. But that is nothing but alpha W1 minus beta W. This implies alpha W1 minus beta W belongs to RT for all W1 W2 belongs to RT and alpha beta belongs to R. So what is the meaning of this? This implies RT is a vector subspace of W. So this is the so rank and nullity of rank and nullity of rank and nullity that P and W be two vector spaces over the same field F and let T equal to W will be a linear transformation. We write rank of rank of T is equal to dimension of RT. Okay, and nullity of P is equal to dimension of T. So rank of T is nothing but dimension of range space and nullity of T is nothing but dimension of null space or kernel. Okay. So example. So once again, what is nullity? Nullity is dimension of null space and rank of T is dimension of null space. That T R to R square to R3 be a linear transformation function defined by T x y is equal to x plus y, x minus y, y. Find null space, find null space, range, space, rank, and nullity of T. Solution. So T R to R cube is defined by x y is equal to x plus y, x minus y, y. What is anti? Anti is x y belongs to R square such that the x y is equal to 0, 0, 0. So let x y belongs to R2 such that Txy is equal to 0, 0, 0. But Txy is equal to this is x plus y, x minus y, y. So this is x plus y 0, x minus y 0, and y is equal to 0. So y is 0 either by this way, what is this x going to be 0, or you can use this one in x going to 0. So this implies xy is 0, 0. So anti is 0, 0. So so nullity, nullity of T is equal to dimension of anti. Dimension of anti, there is no non-zero, only single element 0 is there. So nullity. We do not have any element other than 0. What is RT? Pxy such that xy belongs to R. X plus y, x minus y, and y. Now x plus y, x minus y, and y. How we can write it? X, x, 0, y minus y, y. So this is x and this is. So 1, 1, 0 belongs to RT and 1 minus 1, 1 belongs to RT. Okay. So this implies B is equal to this 1, 1, 0, 1 minus 1, 1 is subset of RT. Span of is this is equal to RT and is linearly independent. This implies you say basis for RT. So how many elements basis has? It has two elements. Now this implies the rank of T dimension of RT is equal to number of elements in basis of RT, that is 2. Okay, so this is done. Example 2. That T R2 to R2 be a linear transformation defined by Pxy equal to is equal to x minus y, y minus z. Find out find out null space, ring space, nullity, and rank of. In earlier example, we can do one more thing. Here we can write like this also. X and y belongs to solution. Okay, and to x, y, z belongs to R cube such that p x y z is equal to 0, 0. So let x, y, z belongs to R such that p x, y, z is equal to 0, 0. So what is this? X minus y minus 0. So this implies x minus y equal to 0, y minus z equal to 0. This implies x is equal to y and y is equal to z. So this implies x is equal to z. So this implies and t is equal to x, y, z, and z. Belongs to R, J, such that x is equal to y equal to z. So what is this? X, 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 such that x belongs to R. But x is equal to x 1, 1, 1. So put this. This is subset of and t. Span of and t. And this is linearly independent. So this implies this is the basis for so nullity of t is equal to dimension of and t. Number of elements in basis B of and t. Now what is RT? Okay. So x minus y, y minus z. How I can write this? So I am taking x, y, z equal to 1, 1, 0 and x, y, z is equal to 0, 1, 1. Then this implies x minus y, y minus z, that is 0, 1 belongs to Rt. This will imply x minus y, y minus z, that is minus 1, 0 belongs to Rt. Next, x minus y, y minus z. How we can write combination of these two elements 0, 1 and minus 1, 0. So what should I write here? Y minus x and here y minus z I should write. It means y minus x minus 1, 0 and y minus z 0, 1. So put b dash is equal to minus 1, 0, 0, 1. And this is subset of Rt span of b dash is equal to this is minus this is 0. Span is Rt and b dash is derivative independent. So rank of P is equal to dimension of Rt. Is equal to number of elements in basis B dash of Rt. That is equal to 2. So this is the answer. So what we go, rank is 2 and nullity is 1. So today's lecture up to this, if you have any comment related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.